Welcome to the Secret Underground Laboratory Recovery and Salvage, where rude mechanicals do magic. Hello, I'm Bronze Age, Director of the Secret Underground Laboratory Recovery and Salvage. And today we have 16 lights to replace on this chandelier. Now, this is a style that was popular in houses built in the 60s on up into the 70s. This scaly bit here is sometimes called a pineapple or a pine cone, but if you look closely you can see little veins which make it acanthus leaves. The top piece here is acanthus leaves, more acanthus leaves here. Each of the bobiches are acanthus leaves, and for some strange reason down here they've got a bunch of fleur-de-lis wrapped all around it. But it all works out the same. More acanthus leaves and stuff like that down here on the bottom. The decorative piece that goes on the top of a lamp or something like that is called a finial. I've never had a really good name for the bottom of them. I call them minials. I'm trying to be delicate taking this off, but it's actually bent, which is fairly common on these kinds of things, because when they get taken out of the original house where they were put to be replaced with something more stylish and up to date, they rarely get treated gently. And, as expected, something broke. And on top of that, it reveals something rather disappointing. It's been wet. Now, this is not the end of the world, especially for this chandelier, since the arms are solid brass. What happens is when it's left out in the rain, the water will get into the bobiches, which act as natural funnels, and it's going to collect here in the bottom of the arm. And being solid brass, there's not going to be the scaly rust like you see on these steel nuts right here, which has the effect of sticking the wire to a large segment of the arm. I'm hoping, being brass, put a little bit of liquid wax down in here and as a lubricant, and then gently pull back and forth like a dental floss, and the wire should come out. Now the problem with a chandelier like this that's gotten wet, whether it was left out in the rain or somebody took it to the car wash and cleaned it with the pressure washer, is that in the bottom here there's an insulator that separates the center terminal from the shell, and it's made of cardboard. And if it's been wet long enough, that cardboard will deteriorate. It will gradually turn into a powder, and eventually you'll have a dead short inside your socket. And that could be 4, 5, maybe 10 years from now, but I promise you it will happen. I've seen it before. Nobody ever saved time or money by cutting a wire short. Now, my preferred lubricant when pulling wires, when a lubricant is needed, because it's most of the time it's not really necessary, is beeswax furniture polish. They actually do sell a wire pulling lubricant that's used by electricians who are doing much heavier duty work than this. I pull the black wire out, and that'll help run the wax down through the pipe and makes a little less to pull through. Takes a little fiddling, but it will go through. Now it's going to happen that you're going to be pulling the wire, and no matter how you wiggle it and pull it, there's some snag inside here. One trick to get around that is to solder another wire to the opposite end and try pulling it backwards. And there we go. And so we're down to the last arm. And I hope I didn't jinx it by saying that. But this one has gone remarkably well. Only one wire giving me any real trouble. There we go. Well now, always got to be one. A little bit of a push on one end and a very gentle tug on the other end. It usually will go ahead and work and come through. I've turned the chandelier on its side because now I have to address the damage from the corrosion. This piece, a little mangled piece of sheet metal, is part of the hickey. It's one half the hickey. The other half is here. It's stamped sheet metal, which is pretty lightweight. I'm going to have to replace it with one that's made from stamped steel, a little thicker. But it goes right there and allows a place for the wires to come out of the pipe that comes down from the top of the chandelier. And there's no set way to get this off. It's just a rusted, basically a nut for all practical purposes. I soaked it in some penetrating oil overnight, and I'm just going to have to play with it till I get it off. Well, every once in a while a product lives up to its name. That was certainly a lot easier than anything I was expecting. Clamping something round in a vise is always a challenge, and especially when it's brass, because that means that you can damage it very easily. So I always end up making a pair of these soft jaws for holding something like this. Because the first thing I'm going to do is just cut this right here and get the rest of the stuff out of my way. Now there's a variety of techniques for getting a rusted steel bolt out of whatever it's stuck into. None of them work all the time, and none of them work very well. I'm going to start off with applying heat. This is just a propane torch. Oh, that came out well. It's real tempting to grab it and spin it out by hand when it gets really loose, but don't ever do that. For the trunk wire, I'm going to use a regular lamp cord set with the plug molded on it. A couple reasons. First, this is going back to a dealer's shop where she's going to have it on display, and the plug just makes it much easier for her. And this cord set is actually some of the cheapest wire per foot you're going to get. Probably cheaper than the wire that you buy on a roll of 200 feet or more. And it'll also give the customer, probably a good 6 feet of extra wire if they want to hang it from a high ceiling. This is a lot of wires. Now I'm using this double cable here that's made for lamps and lighting. And all cable like this, where the two pieces are joined together, they're going to have one side, the insulation is smooth, and the other side is ridged. That's so you can keep track of which end of the wire is which, from the top to the bottom. Now, if you were using separate wires, you'd have a black wire and a white wire. That's the normal standard United States color code. It'd be different in other places. But the white wire corresponds to the ridged wire, and the black wire corresponds to the smooth one. So what I like to do when I'm working with this many wires is take a black Sharpie and make a black mark on each smooth wire, because you really can't see them, and after you've worked on this thing long enough, you kind of go snow blind. And this will help me keep track of which wire is which when I start soldering them together. I really don't think it's a good idea to have a splice with 16 separate wires. So I'm going to break this up into a couple of connections. I say a couple. Actually, probably going to come out more like 8. But what I'm going to do is bundle 4 arms together and then come off from that and eventually end up at the trunk wire. Now, all connections in the Secret Underground Laboratory Recovery and Salvage are soldered. That's really the only reliable connection technique. And my preferred method is, of course, a soldering gun. Problem is, when you've got this many wires, to get it hot enough for the solder to flow all the way through from one side to the other and make sure that you have the good connection, you have to get this so hot the insulation starts to melt. And I don't like doing that. So I had to come up with an alternative way to get the solder into the wires. This is a stove I made, heated by this little mini torch. And what it does is it melts this little pot of solder. Now, regular wire solder that you use for electrical work comes with a core of rosin on the inside of it. And rosin is a chemical that's going to melt, and it cleans up all the oxides on the wire so the solder can get a good, nice connection. I'm not using soldering wire, so I've got my own rosin and a paste, which I put a coat on each connection. And then take my little pot and just stick it in, and I get a really pretty solder connection there. Now, to cover all these connections, I'm using shrink tubing, which is a peculiar plastic that when it gets hot, it shrinks. That was the inaccurately named doorbell. It's irritating as hell, but I need something I can hear when I'm wearing the hearing protection. Anyway, the last thing to button this up is curl the shrink tubing over and put a little loop on it, and then hit it with the torch one more time. And that gives us a nice tight connection that's not going to be exposed to most moisture, and certainly not going to create a short. Now that's some very nice wiring. Last thing I've got to do here is put this nipple that will hold the minial on the bottom. Anytime a pipe goes into a hickey like this, there's got to be a lock nut on it, because you don't want that nipple to screw up inside there where it could come in contact with the wires and actually saw through them, or just through the edges be a source where the wire could get cut. And I always use the blue Loctite whenever I'm putting a chandelier or a lamp together, because I don't want anything in here to come apart while somebody might try to take this off. There'll be a big crystal ball hanging from the bottom of this, and somebody could be playing with it. You never can tell what's going to happen in the future, so you need to try and take care of these sorts of possibilities. The first detail is these rusty pipe nipples. I'm going to be using the blue thread lock on here, and it doesn't stick very well to rust. The other detail is I pretty much hose this thing down with penetrating oil to get it apart, and then I filled it up with beeswax, neither of which would make it also good for the thread sealer, thread lock to hold. So hit it a little bit with this engine degreaser. It'll take a minute or two for that to dry up, but it will remove all the traces of oil and wax, and I can install my pipe nipple. A little bit of blue sealer going into the arm. Now, the Bobiche has a machine space here on the bottom where it goes against that flat, and that's good. But on the top, there's no machine flat spot. And what that means is if I go and try to tighten down this stamped sheet metal light socket, it's really not got a good base to ground out against. It's going to be crooked. It's going to twist these threads, torque them to the side a little bit, and they won't stay tight. Solution to that is a little more blue thread lock, and then a nut that goes down the nipple. And it will form the base for the socket, and be a nice flat square surface for it to come down on. Make that a little bit tighter. Now another advantage of this is these Bobiches have little holes in them for where crystals could be hung, and putting this nut between the Bobiche and the socket means that in the future, when someone tries to twist this because they don't like the way the crystals are hanging, it's not going to loosen the socket at the same time. And I can promise you that no matter which way you line up these little holes, sooner or later somebody's going to decide they need just a little bit that way, just a little bit that way. And that can move just a little without disturbing the socket. And we do this 15 more times, going around 8 arms. 16 sockets installed. Now we're on to the final wiring. These are adjustable sockets set to their highest position. I'll go around and clip off the wires even with the top, because you're not going to need any more than that. Split them open and go around each one, getting the work done just a little faster through repetitious motion. The last step is a detail that really makes a difference between a good job, when I say a professional job, and a poor job. I won't say amateur job, because this is a step that anybody can do. It's just a matter of understanding why it's needed and doing it right. And what it comes down to is stranded wires like this, if they're going to be put under a screw terminal, they have to be tinned. And tinned means that a little drop of solder is put on the tip of each wire. Doesn't have to be much, but the whole purpose of that is to take that bundle of loose wires and make it into one wire. Reason being is that when you put stranded wires under a screw terminal, all it's going to do is splay them out, and you really won't get the screw very tight. They'll come loose. That gets hot. Hot terminals get the whole socket hot. Keeps the light bulb overheated. Light bulbs don't last very long, and eventually the socket burns out as well. Now you'll notice we got a brass colored screw and a silver colored screw. And going back to talking about the lamp type wire before, the Siamese wire, one side is smooth, one side is got a ridge on it. And the ridge side goes to the silver screw. And that will be connected to the socket shell on the inside. Tighten that down. And this one, the smooth wire, goes to the brass colored screw. It's wrapped around in a clockwise direction so that when tighten it down, it's going to draw the wire tight under the screw instead of pushing it out. Get it down nice and firm, making sure it doesn't squeeze out while you're working on it. And that's it. I've got to do the rest of these, and I'll be ready to test this chandelier and make sure everything's in good working order. Well, this will certainly light up the cotillion. So, this is Bronze Age for the Secret Underground Laboratory. Thank you for sticking all the way to the end of this video. I would appreciate it if you would like and subscribe. And I hope to see you again in the next video. Again, thank you very much.